Hello. Today, it seems, that I will be talking about the hard parts of an observability initiative. So this talk is fundamentally an experience report. A colleague and I have been working on leveling up the sort of observability, or more specifically, the monitoring story within Fastly's engineering org for the last little while. I suspect a lot of you are thinking about starting or in the middle of similar initiatives, and I thought it would be useful to talk about the interesting aspects of the successes and failures that we've had so far. I'll step through the life of the project, highlighting the interesting discoveries along the way, and then summarize the key kind of like takeaways at the end. And as kind of a spoiler, as it turns out, the technical challenges are actually the easy ones. The hard parts have largely been social and political. So to understand our operating context, I guess it's necessary to understand a little bit about the company itself. Fastly is an edge cloud and content delivery network. We started in 2011 and have a slightly different take on the market. We use like beefier machines in our POPs and a relatively modern software stack to provide a sort of more featureful and programmable edge product, I would say. Fastly has historically been an engineering org of mostly seniors. And this was by design. It kind of allowed great product and technical velocity, especially at the beginning, but still today, and continued as we grew to a current size of about 120 engineers. But like any technical decision, this one, to build out an org of mostly seniors, has both benefits and risks. Teams of senior engineers bring their experience with them. They also operate quite autonomously. So these are both great qualities, but it has this inevitable result of a sort of heterogeneous mix of designs and implementations and support tooling, including monitoring, of course. Our monitoring universe grew organically, and organic growth of software tends to be append-only. So initially ad hoc dashboards prove their value through the course of time, and then would become canon, but kind of just like through a social sphere rather than any sort of deliberate decision. Incident-driven alerts specialized to specific or quixotic symptoms or incidents would be created, but of course rarely audited after the fact. So over a period of years, these patterns produced highly specialized sort of monitoring regimes, I would say. Essentially, local optima that worked well in the small, but didn't benefit from coherence in the large. To be clear, this is a desirable state, I think, at least to a degree, but even organic gardens need to be weeded sometimes. So we were living with this situation for a while and decided that we had sort of the bandwidth and the desire and the time was right to address this head on and sort of level up the story in the whole, for the whole org. And specifically our metrics. So let's scope out what that means. Now, concretely, we want to be able to answer these questions for all of our production systems. Number one, is the system currently healthy? Kind of true, false. And if not, why not, right? Where can we begin debugging if that's not the case? And even more strongly, we want to be able to make sure that any engineer in the org can answer these questions for any system in the org, even with only an introductory kind of like month one understanding of our infrastructure. So goals are obviously important to direct design and development efforts. Non-goals, I think, are even more important to keep the work well-scoped and the project tractable. Observe that the questions we want to answer are focused on the moment now. Is it healthy? If not, why not? Answering them accurately requires some degree of historical data, but not a lot. So we did some investigation of how our existing monitoring systems were being used in practice by the internal customers that either set them up or were consuming from them. And it turns out that the vast majority of collected metrics were queried only over the last few hours or days. And despite collecting thousands of metrics per host or per service, only a fraction of them were queried with any regularity. The actual usage patterns, which were hugely different than the usage patterns the team said they had, interestingly enough, helped to scope an appropriate sort of set of limitations for the work we were going to do. So we'd only have a short data retention in the initial like version or two of the project on the order of weeks. Anything longer would be a separate initiative after the initial rollout. We're also laser-focused on internal systems owned and operated by the engineering org. We won't build a system that serves other use cases or is subject to external or higher SLAs or SLOs. One common example is surfacing data to customers. So in our industry, or really maybe a bit more generally, like online multi-tenant systems, especially at a global scale, there's a pretty clear line of demarcation between operational telemetry for our own responsibilities that we run and for lack of a better phrase, like customer metrics, right? Data showing us the experience of our customers. We already had a reasonably set of mature systems in place for the latter, and we didn't want to expand the scope or risk profile of this project to include those things. It's also important to understand the role of metrics in the broader context of observability, I think, especially relative to the other two pillars of like logging and tracing. Metrics are a great fit for reactive requirements like dashboards and alerts, and can provide a good like system overview, but they aren't great for investigation or introspection. Metrics are instead complementary to a good logging pipeline, and our system shouldn't try to supplant those use cases, it should try to enhance them. So having identified and somehow scoped the problem, my colleague Marcus and I formed a project team to do the work. We both had pretty extensive domain knowledge. Marcus in Fastly, he'd been there quite a while. Me in Prometheus, I kind of like grew up with that system. And both of us in observability work in general. So this would be our primary, though not exclusive, project for about a year. That's how we scoped it. We did a domain survey and technology review, and we settled on roughly the following plan. First, we're going to deploy Prometheus across the infrastructure, piecewise, but that was the goal. Then we're going to either add duplicate Prometheus instrumentation to services that we wrote. This is like white box, right? Or deploy Prometheus exporters for software that we didn't write, but that we still need to run and know about. Then we would write a new curated set of dashboards and alerts for everything. We would run the state for a while, running all systems in parallel in order to build confidence that what we had built out would be good and suffice and be accurate. And then we decommissioned the old systems on a well-communicated, hopefully set in stone future date. And we would start by paving out all the infrastructure using this thing from, I think it's like a software development methodology. It's called the tracer bullet style of design. That is, we'd build a working solution quickly, but correctly, right? Using sort of proper production grade software development practices, where we do it in the production environment, using designs and techniques that are like production quality. This requires some good degree of familiarity with all the tools and the environments, which takes a little bit more time, but it avoids a messy sort of like productionization step between prototype and good to go. And I think this is the right way to do this kind of project. So to validate that our initial plan would work, sort of like to get a check in that box, we'd pick a couple of services that would cover a reasonable like cross-section of what we do internally. We'd find a couple of friendly and enthusiastic sort of alpha customers, and work with them closely to onboard them to the Prometheus like world. This was crucial. They'd give us context that we were missing when we were like dreaming up our own idea of how this would work, and they'd be a testing ground for the things that, the workflows that we came up with. Some of the services would be third party, and we'd deploy the exporters for those. Some would be in-house, and we'd either instrument them ourselves, or we'd pair closely with the teams to instrument them sort of side by side. And if after a short time box, our alpha customers were happy, I think we'd have a reasonable justification to upper management to carry on with a prototype and take it all the way to production. So the initial spike took just under a month, and like I'm standing here, so you can kind of guess it was a success. The roadblocks we hit were a few, but they were surmountable. And our alpha customers were pretty happy and enthusiastic. So the next step then was to sort of inventory the company, right? See what services we had, where they were running, and sort of priority rank teams and services by whatever criteria made sense, which for us was this mix of production criticality, so like the more important it is, the higher it should be, but also some notion of friendliness in the sense of it's better to have the folks eager to help us out and like maybe test things that we're not totally confident with earlier on in the program while we iron out the kinks and everything. So we did that, and we created kind of like a burn down chart, which in reality was like a spreadsheet with a progress for each service. And of course, the list grows over time as we find more services hiding in the corners. But in any case, each service progressed through stages, right? You kick it off, you instrument, you do the production wire up, you build the stuff out, the dashboards and the alert, and then finally it's done. So we did that, or at least tried to start with that, and then we started grinding it out, essentially, going through the company and making all this happen. And this is where things get interesting, actually. This is where the sort of like the takeaways start to reveal themselves. So our strategy was based on this mostly successful thing I witnessed at SoundCloud, where I was some time ago. We went with this sort of embedded expert or consultant model. where I would personally go through the burn down chart and rotate through each team or each service, sometimes it's a single engineer, in sequence, and essentially pair with the responsible engineer for a period of 1 to 2 weeks. The key realization was that the technical details are pretty rote and not that difficult to do this work. The problem is actually social and educational. That is, getting engineers to understand, first of all, how the Prometheus model works, which is sometimes a little bit different, but more importantly, why the things we're doing are important and necessary. And since many teams have been operating as seniors in these sort of successful, locally optimized silos for a long time, this whole practice boils down, I think, to a practice of building and maintaining empathy. So here's how it works. You can adapt this to your own use if this is useful to you. Step one was generally like an hour or two of pair programming, followed by maybe a round or two of PR review. Prometheus has a good local testing story, which was a big selling point for a lot of engineers who like to work that way. One small mistake I made when going through the teams and doing the instrumentation work was trying to lay out the process exhaustively before the fact. Much of the guidance I came up with in my head would change as we went through the process with the different teams, and it would kind of reify into patterns that I couldn't really predict. What worked a lot better was allowing those patterns to kind of emerge naturally, and then document them kind of post facto. This requires a lot more high-touch work at the outset, but it turns out that's inevitable anyway. The documentation portal that emerged from all of this work would turn out to be an important sort of center of mass in the project, actually. It was a GitHub wiki, or still is a GitHub wiki, with a roughly even split between this like narrative how-to style guides of like instrumenting or building an alert system or whatever, and a sort of FAQ of specific point questions as they arose. And I think about equally useful in both parts. There's also a large section of case studies describing the story of several teams from sort of start to finish. And this was particularly helpful for engineers who are most successful following in the example of others, which I'm certainly among. The real benefit of this documentation portal, though, was, I think, being able to sprinkle every observability-related conversation on Slack or wherever with deep links to answers or breadcrumbs to get more information. This, like truth, socializes and I think reinforces the documentation site as a central source of authority, which in turn makes people a lot more able to help themselves in the future. And since we're only 2 engineers and we probably want to do other things with our lives at some point, this property is really important to like incept in people in the org. Okay, so that's sort of the process for instrumentation. And once a given service is sort of instrumented and deployed, which can take a while, the next step was to get that information into Prometheus, plumbed into Prometheus. And often, especially at the beginning, this required deploying Prometheus to a new corner of our global infrastructure. We certainly didn't predict up front exactly how this would work. We had to kind of take it case by case. And this part of the job was easily the most time-consuming and sort of trickiest technical aspect of the work, especially at the beginning, when we're still discovering and defining best practices. Our heterogeneous services had, of course, heterogeneous deployment models, and it took a long time to figure out a set of best practices for all of them. Even once that was mostly done and we had figured out most of the patterns, new teams would invariably require exceptions. I think over the life of the project, we were probably most often bottlenecked when trying to realize our design or architectural vision that we came up with at the start of all of this against the sort of organic nature of our actual infrastructure. So this took way more time than I think we expected at the beginning. But I guess that's kind of the standard operating procedure for projects of this scope. These challenges were the most tractable or real consequence of a natural tension that I alluded to earlier between letting engineers choose the best tool for their job in isolation, which is a form of local optimization, I think, versus standardizing on a common model and a common set of practices, which is, I guess, a global optimization. The discussion of which one to favor and why, I think, needs to happen continuously in any org and transparently with everyone that has any stake or role to play. My experience is that most orgs don't address this concern directly enough, and naturally, or quickly, bias towards local optimization in service to development or product velocity, which is fine, but I think it needs to be understood as a form of technical debt, actually. Fine to do, as long as it's scoped, and done with a proper accounting of the costs that it incurs. Indefinite deferral of this technical debt, like any technical debt, becomes exponentially more difficult to unwind, and left unchecked can derail teams or entire orgs for years to do that work. And so I think, in a very real sense, leveling up your observability story or your monitoring story can be understood as paying down technical observability debt accrued in service to product velocity. Okay, so once the metrics are being collected into Prometheus, there's a blog post on the Prometheus website that says what the plural is, and it's based in Greek, and I always forget. I think it's Prometheus. Yeah, Prometheus servers. Once the metrics are being collected by Prometheus servers, it's time to do something useful with them. This generally means a basic service dashboard and set of alerts to answer those initial questions: is the system healthy, and if not, why not? Many teams had built both of these things in other monitoring products already, which were generally straightforward to port over. That porting process, of course, shouldn't be just a blind port, but instead an opportunity to revisit all the decisions that were made and sort of weed our garden of these years of cruft. So I asked each team these core questions from before and tried to make sure that we only build things that directly answer them, that are in direct service to those things. A good dashboard is a carefully curated set of visualizations in service to specific goals. It's not everything that could possibly or theoretically be relevant. Similarly, alerts tended to grow over time, often in response to specific incidents, but a good set of alerts is similarly minimal, focused on high-level service metrics rather than low-level technical details. For example, I think it's almost always incorrect to alert on CPU load. I hope I'm not breaking any new ground here in this room. It's always better to alert on things like a 90th quantile request latency or the maximum time a job spends waiting in a queue or something like this. And these are lessons that are well understood in rooms like this, but sometimes need to be socialized very gently in an org of our size. How this work got done was kind of a spectrum based on both interest and available resources and time on a team. On one extreme, the team could take care of it themselves if they so chose. There was eventually comprehensive, step-by-step documentation for how to do this for all concerns on the portal. On the other extreme, and especially at the beginning of the project, I would often volunteer to prototype both things myself and ask them for review and feedback and optimization when I got done. This had the additional benefit of sort of creating the standard universe of dashboards and alerts that had a very similar feel, which I think in the long run will be a nice basis for new engineers coming on board to get a sense of how the systems work. And in the middle, we can model it as kind of like another pairing session, perhaps, where I would teach them the power of PromQL and the horrors of Grafana and all these things. No shade, Grafana, y'all doing the Lord's work. Nothing but respect. So it's easy enough to do research and compile a set of best practices for this sort of thing or any sort of thing. It's even easy to enumerate that reasoning in a clear way, on demand, in classes, in Slack, on documentation sites. What's difficult is convincing engineers with workflows that have historically worked for them that it's worth trying something different in service to higher order, slightly different goals. This is the real challenge of any org-wide hearts and minds project like this. And it's why embedding, or something akin to it, I think is essential. Every conversation I have when embedded in a team begins as a fun little exploration, almost a dance, where I have to identify the context of the other person. I need to do this before I start giving them any information. I have a lot of choices for the type and amount of information to give, essentially where to start the conversation. And if I do that wrong, if I start it in the wrong place, all that information gets lost, and it's kind of like a disaster. In the least bad case, I've wasted 20 minutes. In the worst case, I've created walls in this other person that prevent me from being able to help them in the future. If the goal is to persuade engineers, or really humans, by and large, I think we need to meet them where they are. The promise of greener pastures over there is always tempered by the pain of the journey to get to them. And so we can improve that ratio by making the promise greater or maybe more real. We can do that by delivering clear and immediate benefit, by showing them, if you use Prometheus and create this dashboard today, I can show you a way that your service is misbehaving that you can't see in this other system over here, for example. We can also improve this ratio by making the cost lesser. We can do that by shouldering some or much of the initial burden, by prototyping the things for them, or by pairing with them, or helping them out quite one-on-one. And in truth, I think a successful enterprise or project like this needs to do a fair amount of both. Getting by with something you already know is always easier and preferable to learning something new. I think that's just human nature. So to change the behavior of an entire org, you have to motivate an excitement. You have to deprogram the fear and help people escape the trap of learned helplessness. And the only way this works, I think, is by establishing a connection, demonstrating understanding of their situation, and practicing empathy. So that's what we did or tried to do. As time progressed, a few little things revealed themselves. We have a few major departments within engineering, and each department has several teams, and on each team there's between 2 or 3 to maybe 10 engineers or something like this. As time progresses, service ownership can be indistinct, with many services running very well, but kind of in a maintenance mode, without clear stewards. This isn't a bad thing. It just means that someone in my position needs to do the work to identify owners and to get that work prioritized by whoever is running those Jira queues or whoever. At the beginning, with eager alpha customers, this is pretty easy. But as things sort of drag on and easy wins are won, buy-in at the top of the org chart is actually essential to being able to get this done. Some teams can and will ignore carrot-based motivation, and sometimes need a little bit of nudging with a stick. And at the end of the day, that can only come from senior leadership. So having them bought in to an initiative like this is absolutely essential. Without a clear mandate and deadlines, any org-wide refactor like this devolves into sort of like a forever project with 100% probability. Even with a clear mandate and deadlines, some percentage of teams are always going to be lagging behind, and I think that's kind of unavoidable. Now a few tricky bits, unexpected bits. We anticipated that empathy would be important, but we didn't anticipate just how important it would be. In particular, this idea of fighting learned helplessness was very tricky, and there's no shortcuts to that work, I don't think. A few teams didn't want to buy into the system was considered like production grade, whatever that means. That's understandable, I totally get it, but it's difficult to square with the fog of war and like progressive reification of patterns that define the work that we were doing. What worked in the end was describing what we were building as like a Google-style beta, which I think a lot of people have like an intuitive understanding of what that means. That seemed to satisfy most people who are holding out for this sort of thing. So you can use that trick. We also underestimated the importance of socializing infrastructural and on-call knowledge in the team that would ultimately be owning this infrastructure, which is the SRE team, where both Marcus and I were based. 2, I think, is the perfect team size for quickly developing and deploying a project like this, but 2 engineers isn't enough to run the system in perpetuity. We should have brought in additional support earlier in the process, even informally, in order to expand the pool of people capable of running and maintaining the system, knowledgeable about the system, that sort of thing. Finally, alerting in the world of Prometheus is still kind of a no man's land. Alert Manager is the tool for that, and it's powerful, but fundamentally, I think it's like a half-finished product. We've patched it up around the edges to kind of make it serviceable, but it needs a great deal of love and attention before it reaches the level of engineering maturity that Prometheus itself already demonstrates. So now some things that worked really well, most of which I've kind of mentioned in passing, but just to shine a really bright light on them. The team of 2 is hugely productive. I think it's perfect for projects like this in orgs about the size of Fastly. Communication overhead costs are real and terrible, and I think worth optimizing away. The embedding or consultant model was extremely successful, and I think essential for any project like this. Neither carrots nor sticks in isolation or combination can substantively change practices in large orgs. Real change requires connection, understanding, and empathy. Prometheus itself is, I think, a marvel of engineering. It's simple, stable, resource efficient, highly adaptable to a number of deployment environments, deployment scenarios, and seems to play well in all of them. We're very pleased with this choice. And to get a tiny bit meta, this GitOps style of resource management, I didn't mention this, but this is how we do it, where like a Git repo is the source of truth for infrastructural config, definitely has rough edges, in our case in particular, where it interfaces with Grafana, which has only just started to adapt this, or like sort of retrofit support for this kind of deployment model. A bit tricky, but overall, GitOps, as it's called now, has been intuitive, especially for new engineers. And it seems to be the most correct pattern for this kind of work. So if you're working on a project in this space, you should probably use GitOps to manage your change, like if you're in an org like us. Also, I want to use my podium to say if you're writing tools to serve this space, at this point I think you need a strong story around repository-sourced resources. This means things like online reading of resources from disk and like reloading, a compact resource declaration format. Like I would love to see something that isn't YAML in this space more often. Robust, that is like non-fatal syntax and sanity checks. If you reload a config that isn't right, you need to surface that somehow without crashing. This sort of thing. It's really important, I think. So we're in the final stretches now. It's like famous last words, right? But all signs are mostly positive. Hopefully, I've given some food for thought here, and you can learn a little bit from our successes and mistakes. And I hope I've timed this correctly to take some questions. So thanks very much for listening. I've actually been told explicitly that it's a bad idea to take questions, but I'm going to do it anyway. I can kind of see, oh, here's a question right up front. And I'll repeat them. That's no problem. So we have, yeah, the question was, what is the size of Fastly? I can say that the size of the engineering org is about 120 engineers. The overall company is roughly twice that. I wish I could say with more clarity what that was. I don't know. Yeah, maybe a bit more than twice that, actually. Yeah. Okay, I see a question here. Yes?
How did this project roll out their observability teams fit in with putting engineers on call? Were they on call to start? Did this happen as part of this process?
The question is, what is the relationship between this project and putting engineers on call? And this is like a great question of like historical precedents, essentially. We have historically had, so like, what are we? Like a CDN is like an interesting product, right? Because a huge amount of the engineering work we do is like at the edge, right? And so this involves running our own data centers or like racks and data centers and this sort of thing. So most of our operational like knowledge has been sourced in those teams kind of at the edge. And so what emerges naturally from this, I think, is a more, I hesitate to use it, Google-style SRE thing, or model, where there are teams which are sort of like forward deployed and get pages, and that's part of the deal. And then there's another part of the engineering org, which we call sort of like the control plane, that deals in sort of stuff that isn't so close to the edge, like billing stuff, like the web UI, like data mangling, and like this sort of stuff. So this class of engineers historically has been sort of removed from that. Now we're moving over time to a separate model where I think we can all agree like engineers need to own their services and be on call for their services, but it's a spectrum and it's a transition process. So to answer the question, sorry, that was a lot of lead up, this work is completely orthogonal to the like on-call question. We have had engineers on call historically, and we're continuing to put more and more engineers on call, and maybe this is just like grease for those wheels, I would say. Yeah. Okay. I see a question here, yes? Yeah, you. Yeah, so the question is, how do you get engineers to maintain systems after they leave teams? And this is a hard question indeed. I wish I had a correct answer. I can tell you what is like the platonic ideal of an answer here, which is like systems need to be owned, right? Ownership is, in one sense, the one or two people who wrote the system that you know they can go to answer questions. But in another sense, ownership is the on-call rotation which receives pages for the system. And hopefully the engineers who wrote the system are part of the on-call rotation. But as you know, engineers drift between teams over time, that may not necessarily be true. So I think there's these two things to keep in mind. And like I would love to say that we're doing a wonderful job of this, but again, it's sort of like a process of how to deal with engineers who like whose interests move forward and their systems maintain alive. And the way we're answering it so far is to have, and I think probably most of you are in the similar situation, I've seen this many times in my personal career, have a team who ultimately like receive systems in maintenance mode and then are responsible for operating them. And systems go from like experimental to fresh in production to old in production to maintenance mode is like a life cycle thing. And in so doing, rotate through the team that develops, or like maybe the research team, then a team that develops and runs it, and then finally in this like maintenance mode, operations or SRE team. So that's kind of how we're doing it now. And over time, we're pushing more stuff to stay in the development team for longer, I think. Yeah. I think I have time for maybe one more question, so maybe, yes, hello, yes.
So what was the handoff process like from, you said you did consulting on the team, and then, so what would you do to hand off once you left the team to move on to your next embed?
The question is, what's the handoff process like once I leave an embed in a team and move on to the next team? And I guess you mean for the Prometheus observability stuff, right? So yeah, it's a great question, and it's important to state that every embed begins with a little email to all the engineers, the manager, and sometimes the VP level person for that team, where I say, hello, I'm very excited to be joining this team in order to help you create your own observability story in this new world, right? And I am your expert consultant, and I'm going to sit with you, and I'm going to do these things. But when I leave the team, these things belong to you. And you're happy, I'm happy to field questions, but I'm not going to, like, you don't come, I'm not going to respond to you if you say, the alert works this way now, and I want it to work this way, right? You have a week to learn how to do that yourself, and I will happily tell you, like, how to make that happen. But once I leave the team, you're making the PRs. Right? And so that expectation is encoded and made very clear at the beginning. And the sense of ownership is also made very clear. Of course, people push back on that, right? It's not always so simple. But if you have a consistent messaging, you can at least say, look, I told you from the beginning, so that's what's up. Okay, I can answer more questions later, but I think that's my time. Thanks again very much. I guess I take this.